You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 74 of the Common Descent Podcast.
Welcome, everybody.
Today, we are discussing South America.
We've done a few location episodes.
Mm-hmm.
We did Australia and Antarctica. This is our third continent.
Yeah.
And what a continent to choose.
Oh my gosh, there's so much. But I'm excited because this one has lots of weird stuff, lots of weird fossil stuff, and it's an awesome continent today as far as life is considered. And so we're going to talk a little bit about what is Southern America, what does it encompass today, and what is it known for. But then we're going to look at how has it changed throughout time, what are some of its notable animals, how has it moved around, on the planet, with a focus on the weird mammals, because one of our requests was specifically for that, because this episode was requested.
Oh, by whom?
By one, our patron Nils.
Thanks, Nils.
And Shaylee.
Hey, thanks, Shaylee.
Who asked us to talk about weird South American mammals.
Which we've done a little bit.
Yes.
We talked about sloths, episode 24. But now, as always, a view of South America from space.
Yes, because probably more times than I've had in other episodes, did I keep coming to sections and being like, putting the notes together and then having to step back and go, you know what? Someday someone can ask for an episode on this section.
Yep.
Because I just can't.
I can think of several of those off the top of my head.
There's so many cool things. So that's the plan for the episode. But first, some announcements. As usual, at least so far it's been the usual, we like to shout out the names of certain patrons on our Patreon, because if you sign up at a certain level, we'll announce you. Like this. Welcome, Rosa and Tawny.
Welcome, friends.
Yeah, thanks for signing up on Patreon.
Welcome to the Baskin Coil. I guess we haven't officially defined what the Baskin Coil. I guess I imagine that it's just everyone who listens.
That's how I've often used it, is just everyone.
Listeners.
Yeah.
The community. If you're listening now, you're worshiping right now.
You just get the official welcome this way. And then the only other bit of announcement we have is that currently up on our social medias, we have a questionnaire up for you for our end of year Q&A.
Yeah, we got a bunch of questions already as of this recording.
Yeah.
So keep an eye on our Facebook and Twitter, and we'll link it in the description for the episode. Click the link, it'll take you to a Google form. Ask us any questions you have. Last year's Q&A was like 2.5 hours long. Let's see what happens.
Yeah, I'm sure it won't be, much more than that this time.
This one will last through January.
Keep us busy. And that's it for announcements. Short announcements this time. So that leads us right into the news.
News.
So every episode, as many of you know, we like to gather up some of the recent paleo-evolutionary newses that have hit the interwebs and present them to you, like this one coming up.
Hey, that's me. That's my cue. That's my co-host, master of segues.
I've never ridden one.
I'm going to start with the news. Oh, this guy. About a really intriguing fossil ape.
Cool.
That is a new species, always cool, and has some intriguing hints about the evolution of bipedality.
Ooh.
Hey, this is research by Madeline Bohm et al. In Nature. So you know it's...
notable.
Yeah. And we'll link to little tongue-in-cheek jabs at Nature for all the sciencey folks out there. And we'll link to a popular article in Cosmos by Natalie Parletta. The Miocene epoch, big deal time for apes. As we've discussed here and there in the past. Episode 7. And then anytime we have Allie on, we talk a little bit about Miocene apes. This particular new species is from around 11 million years ago in Bavaria in Germany, and it has been named Danuvius guggenmosi. It's notable, 1, for being a different type of ape, always cool, 2, for being preserved fairly well.
Cool.
The researchers identified at least 4 individuals, including, and this I think is really cool, 1 male, 2 females, and 1 juvenile.
Huh.
And what's fun about that is that you get a whole sequence.
It's a nice variety.
It is, yeah. It's a good overview of the species, perhaps.
This variety is the spice of statistical data.
Yes, it is. The male in particular is very complete, including many parts of the body, particularly notable limb joints, which are especially useful when trying to interpret locomotion. Overall, the researchers mention that the body proportions are similar to bonobos. Bonobos? Somebody out there yell at me. I don't know.
I always forget that there's, yeah.
So you can picture, so if you don't know bonobos, they're like really nice chimps.
Polite, chill. They're chimps that have been through therapy.
They're hippie chimps.
Yeah.
They're very hippie chimps. But the most interesting thing about this new research on this new ape is the way its body appears to be adapted for moving. As we discussed extensively in episode 18, there is this big ol' question around how bipedality evolved in our lineage. The habit of walking on 2 limbs. Lots of primates today move in lots of different ways. You've got your knuckle walkers and your swinging, your brachiators through the trees. You've got monkeys that sort of are arboreal quadrupeds, that they walk on all 4s through the branches.
Yeah.
Which of these locomotor styles predates true bipedality is an interesting and open question. Perhaps answered in part by Danuvius. The authors note that its arms, for example, are rather long. The joints around the elbow and hand appear to be very flexible, which are traits that we see in climbing primates.
Okay.
So it looks from the arms that it was a good climber. The legs and the hip, so the hip and knee joints, indicate a more upright posture, and the ankle joints are they were described as stable, so sturdy and strongly built lower leg bones are traits that we see in more upright bipedal walkers. So it appears to maybe have been doing both. They also note that it has a grasping big toe.
Lucky.
So even its toes, even though it has this more upright posture, still grasping, maybe they point out for walking on branches like some modern monkeys do. So they describe a new type of locomotor behavior that they describe as extended limb clambering. Basically, tree swinging and walking.
Huh.
Possibly up in the trees.
So Disney Tarzan.
So Disney Tarzan. They note that this body shape seems to combine adaptations for both bipedal movement and suspensory, so swinging and climbing adaptations. And might be a potential predecessor of true bipedality.
Interesting. That is a very unique amalgamation of traits. It's always interesting to me what traits do show up early in a behavior or a style of survival, and what traits don't go away in the order you might think. Like still having grasping toes is something that you think would be one of the first things to start getting sidelined as soon as you start walking upright at all. But the fact that they still have them is really intriguing.
Yeah, the way they describe it makes it seem as though, if they're right, this lineage of apes became bipedal while still in the trees, at least in part. You are using a more upright posture while still climbing.
I like that idea a lot, especially just because the history behind bipedality, it has always been a big question and somewhat mystery, and at least in the initial sparking of it, but also why has been a big, why did we start doing it? And, grasslands have so often been pointed to as the reason why, so that we could walk around over the grass and be nomadic. But if being bipedal in the tree was useful, there might not be any reason for that grassland catalyst to have happened.
Yeah.
That's really interesting.
Now, people who paid attention to episode 18 will no doubt be thinking, but this ape that we're describing is several million years older than the earliest bipedal hominins, right? Our earliest, like Australopithecines and such.
Mm-hmm.
So this might not be the exact line that our particular ancestors took. This is a very early apparent adaptation for walking on two legs. So it could be that our even earlier ancestors were already kind of inclined to two-legged walking, even before, right, this is before the chimp-human split.
Yes.
So maybe there were even more ancient apes that had a more upright posture. It's also notable that all living apes today are capable of some bipedal locomotion. So it may not be all that surprising that walking on two legs is something that has shown up early and perhaps in more diverse circumstances than we may originally have realized.
Neat.
It's pretty cool.
Well, my bit of news has to do with a pliosaur. Hey, we talked about those.
We sure did back in that other episode, 72 or something.
That was discovered in a cornfield in Poland. This is not a particularly unusual pliosaur, but it does indicate some things about that area.
Hey, what's a pliosaur?
Pliosaurs are those big four-flippered aquatic reptiles. Swam the oceans during the Mesozoic, during the time of the dinosaurs. Long crocodile-esque face, short neck, same group as the long-necked plesiosaurs.
Yes, not to be confused with the two large-flippered, long-tailed mosasaurs from episode 51.
Yes, or the four-flippered but powerful-tailed, long-nosed ichthyosaurs, which we haven't talked about yet.
From episode something in the future.
So
from episode 97.
Yes. I'm putting the bet down now.
Someone's going to hold us to that. I make no promises.
You heard it here first, everyone.
Yeah, right. So we'll see you in September.
This research is by Daniel Tyborowski and Błażejowski. And this is in the Proceedings of the Geologists Association.
Cool.
The article we'll be linking to is by Mindy Weisberger in Live Science. So this fossil was found, as I said, in a cornfield in a Polish village in the mountainous region of Poland. This is significant because up until this, Jurassic pliosaurs were not usually found in many European countries and had not been found in Poland.
Oh, that's fun.
Until this one. So yeah, the first Polish pliosaur.
From the Jurassic.
From the Jurassic. And this is also interesting because of what was found with that pliosaur. There is a few other marine fossils, some crocodilian cousins, some ancient turtles, and some of the long-necked plesiosaurs.
Ah,
so it wasn't just this one big one.
Fun. Episodes 260 and 72.
Now, this is a sizable pliosaur, it seems. The cone-shaped teeth they found and fragments of the upper and lower jaw had some teeth that reached up to 3 inches long.
Ooh.
So this is a sizable individual, at least, and was dated to somewhere between 145 and 163 million years old. The reason this site was notable past just having a cool big pliosaur is that the variety of Jurassic fossils, these crocs, turtles, and plesiosaur pliosaurs, indicate that this was likely some sort of, as the article put it, hub where marine habitats were overlapping.
Oh.
Yeah, because these individuals don't necessarily, or these species and these animals don't necessarily overlap at all times. So going back to the Jurassic, these mountains would have been an archipelago, a grouping of islands surrounded by as they said, warm lagoons. And the reason this seems to have been some sort of overlap is because the turtles and croc relatives typically are known from more Mediterranean sites. So warmer waters that would have been in the Tethys Ocean, the ocean that was between Gondwana and Laurasia, the two major continents at that time. While pliosaurs and plesiosaurs and ichthyosaurs were more common in cooler, more northern waters. So this seems to indicate that there was some mixture, some intermediate, where all of these were able to mix in and become fossilized in nowadays Poland.
Interesting.
Yeah, so seems to be an interesting site. They're hoping to find more in future excavations.
It's always fun when you find the first of a thing in a new place, because it's not surprising when that is also indicative of a type of environment you haven't seen before.
Yeah.
Or some type of preservational state or time. So, yeah, that Poland, who knows what treasures are waiting in Poland.
That'd be so cool for them to pull out more weird marine stuff.
Well, that's fun. Hey, speaking of interesting new fossil sites, my next bit of news is about a site in Colorado, here in North America, that preserves a stretch of time cataloging ecosystems immediately after the end Cretaceous mass extinction.
Cool time to preserve.
It is indeed. This is research by Tyler. Now, here's the thing. So I know two people who know this man named Tyler. And one of them says Tyler Lyson, and the other one says Tyler Leeson. And the second one tells me that Tyler has told him that it's Leeson. So Tyler Leeson et al. In Science. If we've mentioned Tyler before and I've mispronounced the name, I apologize. Tyler Leeson et al. In Science, and it's in Science, so you know it's
science.
Notable. And we'll link to an article in the New York Times by Nicholas St. Fleur. The fossil site is Corral Bluffs in Colorado. The area includes numerous localities with lots and lots of fossils in a stratigraphic sequence, that is, a swath of time, that preserves, according to the paper, the last 100,000 years of the Cretaceous and the first million years or so after the Cretaceous ended.
Oh, wow.
So about 1% of this stratigraphic sequence is at the end of the Cretaceous. Then the mass extinction happens in episode 5. Major dinosaur extinction, aquatic reptiles, things all over the world. And then several 100,000 years of recovery preserved at this fossil locality, which makes it an incredible place to study how ecosystems reacted to the extinction.
Yeah.
They have found so far over 1,000 vertebrate fossils, including 16 identified species of mammals, which is real cool, and then remains of all sorts of reptiles and other stuff. Their plant remains include over 6,000 leaves and over 37,000 pollen grains that they've cataloged and examined.
Whew.
A lot of these fossils are extraordinarily well preserved. So leaves, obviously, that's a big deal to get preserved. Also, like entire skulls and largely complete remains of a lot of these mammals. The article that I read that we'll link to noted that it includes entire skulls of some mammals that have formerly only been known from the teeth.
Oh, cool.
So not only is this preserving a unique stretch of time, an important stretch of time, but it's a really, really impressive fossil site. Or perhaps set of fossil sites. So as they go down the column, they can watch how the ecosystem rebounded after the mass extinction. And they find some cool things. And they were able to date this sequence using a combination of paleomagnetic dating and uranium lead dating, which is one form of radiometric dating.
Nice.
Episode 12. So they have a good sense of what's the timing of these fossil remains. In the plant realm, they found that for up to thousands of years after the extinction, it was lots and lots of ferns. And then after that, for hundreds of thousands of years, palms took over.
Oh, not palm trees.
Not palm trees, episode 73, because those don't exist. But palms. By the time you get to 100,000 years after the boundary, you start to see larger mammals reappearing. So mammals before then were small rodent-sized. Around 100,000 years, you start to see mammals hitting raccoon size. And at around that time, mammal richness doubles. So you get a bunch of new species, you get this increase in body size at around 100,000 years after the event. Fast forward down the column or up the column, 300,000 years after the event, you get an increase in plant diversity, including walnuts, notably, and mammal size increases again. So now you're getting things that are like the size of small pigs, and an increase in herbivores, along with the increase in plant diversity. And then you keep going, and they noted at around 700,000 years after the extinction, you're seeing things that are wolf-sized and capybara-sized, and the oldest legumes in the fossil record. That is the bean family.
Neat.
Of plants. So they've got this awesome sequence of how this ecosystem is rebuilding itself in terms of plants and mammals. And they note that each of those significant time intervals where you get new radiations of animal and plant life and increases in body mass also appear to coincide with times of warming climate.
Oh.
So there's a lot happening here, and it's a really cool fossil site to suss out some of these questions.
That's such a nice cataloging of events and multiple sources of data. Like the fact that they were able to date it with multiple things that are good dating tools. This is a really cool fossil site.
Yeah, it is.
I want to go to there.
It's I want to go see. The article ends by pointing out that there are, of course, plans for future examination. One avenue is that the researchers want to start looking more closely at these mammal skulls, get some CT scans, get some up-close examination to learn more about how these mammals were actually living, and take a closer look at those climate shifts. How exactly was the changing climate related to these shifts in the ecosystem? Because these are all important and intriguing questions to ask.
Awesome.
Yeah, so look forward to more about that.
Yeah, that's what I was going to say. This is one that I'm really, really excited to just see pop back up in the news somewhere down the line.
Yeah, we'll talk about this more in episode 97 when we do Ichthyosaur.
We're going to have to hold on to that news now.
Yeah.
All right, well, my final bit of news is about potentially the oldest carnivorous dinosaur.
Huh.
Yeah. This is research by Christian Pacheco et al., published in Peer J, and the article is by Bob Yurka in phys.org. So this potentially very old, or it is very old, but potentially oldest carnivorous dinosaur was found in Brazil, which is in South America, which is convenient.
Oh, which is in check notes.
I was
South America.
I was half tempted to get a piece of paper to go, which was in South America.
South America. Hey, that's a convenient link. My co-host, some hotshot.
This new dinosaur named Gnathovorax cabreri.
That's a cool name.
It's a cool name. The species name is after the researcher who discovered it, and the genus name roughly translates to, in Latin, a jaw for devouring things.
Cool.
which is very eldritch horror.
Sarlacc.
Yes. And you will be digested for 1,000 years. This dinosaur appears to be a member of the Herrerasaurids, which were a group of theropod dinosaurs, so two-legged, mainly predatory dinosaurs. And this one is notably old. It is dated back to approximately 233 million years ago.
Wow.
So we're in the Triassic, and South America is still part of Pangaea at this time. So this is one of the earliest dinosaurs, period. Appears to be the earliest carnivorous dinosaur. It's significant because we don't know a lot about early dinosaur evolution.
Sure don't.
The fossil was also notably intact. Intact enough, in fact, for the skull to be CT scanned.
Oh, good.
They got some information regarding the brain, which seems to indicate that it probably had good balance and good eyesight.
Nice.
Which would make sense if it is a pursuit predator and
True.
chasing down its food with the sharp teeth and claws that it does also have. So very predatory, pretty straightforward on that. The part that surprised me when I was reading the article and is also very notable is it's not small. Like usually when you say, early Triassic carnivorous dinosaur, you're thinking, maybe wolf-sized. This is like horse-sized.
Wow.
This thing's actually pretty big. Approximately 3 meters long and probably maybe up to 1 ton.
And it's a dinosaur?
And it's a dinosaur.
Huh.
Which means that for the time, this was probably one of the biggest predators in this area and likely represents one of the apex, if not the apex predator for this area. So this was like not only one of the earliest, if not the earliest, but also one of the biggest predators of that time. So yeah, Nathavorax.
That is very surprising. When you say... So early dinosaur evolution, as you said, is very unknown. In fact, the first time we ever did a But We Digress episode was specifically because early dinosaur evolution is so confusing. And trying to sort out theropod meat eaters from others is very difficult. A very large, apparently clearly predatory dinosaur from 233 million years ago sounds so odd to me that it makes me wonder if something went wrong.
I had to double check when I was taking notes and I was going through and I breezed past the meters for a second and then it said 1 ton and I went, wait, did I read that wrong? Have I been looking up too many big animals for notes before this? Yeah.
That's a big dinosaur.
That's a scary dinosaur, which is not usually what I expect from the Triassic.
That is very interesting.
Yeah.
I will be interested to see what others make of this as it moves forward.
Absolutely. And we'll get to talk a little bit more about other dinosaurs from this time period later in the episode. Because this is not the only early dinosaur from South America.
No. South America, in fact, is famous.
Famous.
So name one of the earliest Triassic dinosaurs, and I think all of them are South America. I know there are some slightly later ones that you get in North America, but I'm pretty sure, if you look at a list of the top 3 or 5 or whatever earliest known dinosaurs, I think they're all South American.
Yeah, so now we have a new member for that list.
Well, that's pretty awesome.
Absolutely. And with this, we're going to wrap up news, play a little ditty, and then we're going to start talking about the cool, awesome continent of South America. So South America is by no means a mystery when it comes to the topic of discussion of wildlife and biodiversity and even fossil biodiversity. We're going to hit on some that I think don't get as much attention as they should. But, a lot of the fame for South America is well-deserved. It is an impressive landmass. It's the 4th largest continent, so it's big. It has a huge diversity of ecosystems and geography, which is one of my favorite things about it. A lot of other continents kind of get stereotyped by some of their main ecosystems. And South America, that happens, but it's easy to forget that it actually has major arid regions, huge mountain range, which it's famous for. But in there, it also has cold, truly, cold climate areas, as well as the tropics that it's famous for.
Yeah.
So I want to dive in a little bit here, look at what South America is like today before we go in and talking about how weird it used to be versus how weird it is now. Like, it's never not been weird. It's still...
That's sort of its shtick.
Yeah, it's still super weird and awesome.
It's no Australia.
No.
But it's an odd place.
And truly, it's probably no Australia just because it's holding hands with North America.
Oh, and now.
Yeah.
Like, if we went to South America like 20 million years ago, it would have been much more Australia-esque.
One of the websites I was taking notes from had a line that said, if you visited South America, before North America and South America reattached, it would be like visiting Australia today.
Yep.
And that's a perfect way to describe it. It was very Australia, and then North America came along and got rid of a lot of that Australia.
Someday we'll do a speculative evolution discussion about a world with only separate continents.
Yeah. Oh, yeah, with no isthmus of Panama. So, some of the major features of South America. One of the first ones that I think's important to mention is the Andes. For this is the main mountain range in South America and one of the main mountain ranges on the planet.
Yeah.
This is a ridiculous mountain range. So this runs along the far western edge of the continent. So just right down along that side, almost the entire length of the continent.
Yeah. For you geology nerds, it's where the Pacific is subducting underneath the continent and forcing these mountain ranges.
Absolutely. And this is the world's longest mountain range.
Cool.
Covering 8,850 kilometers or 5,500 miles.
Wow.
So very long. And it also has some of the highest peaks in the world. Second for average peak height only to the Himalayas. And its tallest mountain is also the tallest outside of Asia in the Himalayas. So the tallest one stands almost 7,000 meters tall. So this is big mountain range, long mountain range, big mountains, many of which are also volcanic.
I was gonna say.
Yeah.
Ring of Fire.
Yeah.
Is the lands around the Pacific where you've got lots of subduction zone activity happening. And subduction zones are great places for volcanoes.
Which I didn't know before I was doing this research. I always kind of saw the Andes as a very Himalaya-esque, range, which is still cool and awesome, but I didn't know they were belching fire.
Yep.
Which makes them better.
Also lava.
And this is where you get a lot of the cold climates in South America as well. So there are areas in the upper ranges of the mountains that are truly what we would consider cold climates, being on average less than 10 degrees Celsius.
Whew.
So the mountain range also gives them a huge variety of climate. Also along the coasts are the coastal plains of South America. These are your drier areas. The Atacama Desert in the western coastal plain is actually considered one of the driest regions on the planet.
Whew.
Average rainfall is about 1 millimeter or 0.04 inches a year.
Oh my goodness.
There are some parts of this desert that have never received rainfall in recorded history. Humans, since we've been paying attention to write stuff down, have not experienced rain in those areas.
Wow.
So cold regions, very dry regions. You got some huge variety before we get to what South America is known for.
Yes.
Which are the river basins.
Yep.
So, yes, most of South America is very wet, is very rainy, but there are areas that shirk that stereotype. The river basin being an area where a basin, so think of like a bowl in the land, where water drains into and forms a river system.
Right. So anywhere, the river's watershed, anywhere on the continent nearby where if you spit, it's going to end up in the river.
Yes.
That's the river basin.
And there are three major ones in South America. The Orinoco.
Mm-hmm.
The Paraguay.
Mm-hmm.
And the Amazon.
Yeah, I've heard of that one.
Always forget that one. The Amazon River Basin occupies about 38% of the continent.
Jeez, wow, what a river.
It occupies 2.6 million square miles and is to quote one of the articles I was reading, the mightiest river by far in terms of volume and width in the world.
Yeah.
Largest watershed in the world, flows more than 4,000 miles, with at certain parts being more or almost 30 miles across during the wet season.
Yep.
So, big river.
It's a big, and it comes, if it's from the west to the east.
Yep.
Just Andes, Amazon River Basin, across to the Atlantic Ocean.
About 1/5 of all running surface water on the planet runs through the Amazon.
Wow.
1/5.
So you can imagine in a river basin that obviously there is the Amazon, but then all of the tributaries, all the streams and creeks and minor rivers and major rivers that feed into the Amazon proper, and then the delta systems at the end. This is all Amazon River Basin.
The size of this river was really made apparent to me when I read the next little factoid, which is that it is greater in volume, meaning it moves more water than the next 6 largest rivers combined.
So it's an impressive waterway.
But it is the second longest.
Oh, well, yeah, I'm not impressed anymore.
So close.
Is the Nile the first
The
one?
Nile.
Okay.
The Nile.
Yeah, I thought so.
One article, though, said that due to discrepancies in measuring, they are so close that there's some experts that say they're effectively the same.
Yeah.
Like, the typical length of the Nile is 4,258 miles. So it's just a bit. So it's not a notable second place.
They're in the same weight class.
This is the Olympics when it's, all right, we have to wait until they check the camera and get to the frame.
And the Nile wins by a nose.
Yes. This is also a crazy biodiversity hotspot within South America, home to somewhere around 2,000 species of fish, including hundreds of species with electrical abilities, not just the electric eel, but other electrosensitive fish.
Cool.
60 species of piranha.
Wow. I didn't know there were 60 species of piranha.
Not all of them are the flesh-eating one. There are lots of fruit-eating and other... There's also my favorites, which are meat-eating piranhas, but just go and like nip little bits of fin and like dead skin off of it. So they're just annoying piranha. They're not...
predatory grazers.
Yeah, they're not vicious. They just come over and stop it.
We don't have to talk about this in detail, but you did just say fruit-eating piranha. And I just wanted the listeners to make sure that, yes, you heard that right.
With horrifying human-looking teeth. Ugh. And then you also get things like the Amazon river dolphins, which are the largest species of river dolphin.
Cool. They have the most space.
Yes. And et cetera. I could go through what lives in the Amazon.
Oh, yeah.
So ask for an Amazon River episode later on. There's also the Amazon River reef, the reef that's growing under the outflow of the Amazon River.
Yeah, we talked about that in episode 36. You mentioned that reef.
So go listen to that one for that. Because once again, if I go into every cool detail about South America, we will never get to the stuff that's gone extinct. The Amazon River is also vital because it is what directly feeds the Amazon rainforest.
I've also heard of that.
Yeah. Amazon rainforest makes up about half the rainforests of the entire planet. And it is the largest and potentially oldest rainforest in the world today. That's still around today, I guess I should say.
It's like quintessential rainforest. And in fact, I think in the last episode, Allie made a comment about how that is what a rainforest is.
Yes.
Like, if there's like a holotype for rainforest, the Amazon.
Absolutely.
Whew.
And man, talk about biodiversity.
Oh my goodness.
Wow. So biodiversity in animals is crazy. I'll go over some of those numbers first, but the plants are really what blows my mind. The estimated species of trees, number of species of trees in the Amazon rainforest is 16,000.
Wow.
There is a tree for every year we are estimated to still be digging at the Gray Fossil Site. So it is
a tree species.
Tree species. And
wow.
The density of trees is also insane. One survey found within a single acre 100 different tree species.
Trees on trees on trees.
Trees on trees on trees. In 1 square kilometer, it was estimated there to be roughly 90,000 tons of living plants.
Wow.
It is just life crammed in on itself.
Cool.
And then within those trees, you have animal life that I'm not going to go into all the different kinds of cool animals. I'm going to give you some numbers because, oh my God, these numbers. Roughly 20 million species of insects. And then one article just had hundreds of spiders and butterflies, like specifically.
Yep.
Somewhere around just below 1,300 birds. Bird species.
Yep.
More than 400 mammals and 400 amphibians. So 400 of each species. And almost 400 reptile species.
I want to point out that number of mammals and birds is roughly 10% of all mammals and birds.
Yep.
Jeez.
It's insane. And then on top of these crazy numbers, and not to be unexpected when you're dealing with such insane numbers, is the number of endemic species is also ridiculous.
Oh yeah, endemic species meaning species that are not found anywhere else.
Yes, they are specific to this locality. So within South America, there are huge numbers of South America specific species, endemic species. In plants, they said, especially among angiosperms, no fewer than 25 families and 3,500 genus of plants are endemic to the tropical and temperate zones of South America, and 89 families and some 3,000 species of bird.
Wow.
Throughout all of South America are endemic there.
Wow.
So just the numbers here are ridiculous. And many of these numbers probably will be adjusted as newer surveys come in and older surveys go out of style, and trying to find which numbers were the most reliable ones, it was tricky because different reliable sources would give me slightly different numbers.
Right.
So don't take these numbers as like the ones you have to do math by.
The take home
is there's a bunch.
There's a lot of diversity in South America.
It's insane. It also has some notable things for just the cool kinds of animals it has. 2 that I just want to give some credit to, because, I picked 2 out of a bag. It does have the world's heaviest snake.
Sure does.
It's got the anaconda. So you got anacondas down there. The heaviest snake and second longest.
I think so. It's in that realm of
ridiculously
these are all
long.
The long snakes. But yes, second longest. Only because there are some crazy long reticulated pythons.
Those record holders. But it has the big, heavy anaconda. It's one of the places in the world where a big snake ranks as one of the apex predators.
Yeah.
Which is cool. And my favorite thing about South America, it is the highest density of crocodilian species of any continent, with 8 species.
Wow.
Not counting subspecies. All 6 caimans and 2 crocodiles, the Orinoco and the American crocodile, all can be found somewhere within South America.
It's a pretty cool place.
So it's just ridiculous.
Hey, listeners, tell us your favorite South American animals.
Oh, please
or
do.
Plants.
Yes.
Let's not leave out plants, Allie.
Allie, you tell us your favorite.
Yeah, so we'll get her back on.
So lots and lots and lots of cool species. If there's any part of that was far too brief for you, it was far too brief for us as well.
Give us requests of what you want to hear more about.
Let us know which part of that you want us to talk about more. But we've got to turn the dial back and start talking about where did South America come from and how did it get to be the way it is.
Indeed. Real quick note, of course. Also, islands.
Yeah.
Like the Galapagos. Famous islands associated with South America, too.
True. It's just, there's the list of
there's
cool
so
things.
Much.
I found so many good articles that I had to just breeze through.
Yeah.
So let's go ahead and start looking at the history of South America. We're not going to go through it in its entirety. I want to focus mainly on some of the most notable fossil-rich time periods that gave us some really peculiar, cool fossil groups. But first, to get the foundation set, let's talk about how the foundation of South America got set.
Oh.
So the actual formation of the continent, I found could typically be summarized in 3 different developmental stages, since that's the way it was listed on the sources. The first one being the Precambrian. So we're more than 500 million years ago. We are looking at when the core bits of crust came together to form South America. These are called cratons. And there are 5 that make up South America. The Amazonia, the São Francisco, the Luis Alves, the Alto Paraguay, and the Rio de la Plata. These crushed together during this time, and many of these rocks are still able to be dated in South America. The oldest dated rock goes back to 3.4 billion years old in Brazil.
So over the span of the first 4 billion years of Earth history, all of this tectonic foundation is creating the continent as we know it.
Yeah, so creating what will eventually be a South America thing. Crushing together. Second stage goes into the Paleozoic, during which time those cratons have fully accreted themselves to one another, and over time become part of the supercontinent Gondwana, the southern supercontinent, which then becomes part of Pangaea. And so we're breezing through these periods.
Oh yeah.
But smushed together into Gondwana, so it was always part of the southern portion of land.
Right, along with Africa, Australia, Antarctica.
Exactly. And then that gets smushed in with everything else into Pangaea, which rolls us into the next phase, going into the Mesozoic and up to today, which is when things start breaking and moving into what we recognize. So Pangaea actually does not last very long. We've mentioned this before when we talked about our previous continents, but Pangaea formed and then almost immediately started breaking up, in which point, going into the Mesozoic, South America starts moving away from Africa. So it was attached to Africa only in the early Mesozoic and starts moving away pretty quickly with the Atlantic Ocean, the southern Atlantic Ocean, opening up and pushing things sideways. And as we go into the Mesozoic, it's still connected at this point, actually, to, for a short time, North America and Antarctica, which is connected to Australia still.
Mm-hmm.
So this is kind of the way things are going in the Mesozoic until we get to the late Cretaceous, at which point it has actually separated from North America and now is only attached to Antarctica, which is still attached to Australia. And so before we follow it, it's on its path further, let's pause here in the Mesozoic, where for most of the time it's connected to North America, Antarctica, and by proxy, Australia.
So it looks like South America.
Yes.
Like you'd recognize it as South America by this time. And you've still got these lingering connections, but it's the Mesozoic.
Exactly. So let's pause here and look at some of the weird stuff that was living on South America during this time.
Yeah, in the earliest times that it was recognizable as South America.
Yes. There's lots of cool fossil animals that have been found in South America. I wanted to look at some of the notable dinosaurs that have been found there, because there are some weird ones and particularly famous ones.
Yeah.
First and foremost, being the first ones, early dinosaurs, as we mentioned at the beginning of the episode, are really well known in South America.
They sure are.
And so Triassic dinosaurs, we mention Gnathovorax in the news, but probably the most well-known or popularly well-known is Eoraptor.
Yeah.
Eoraptor for a long, long time was known as the earliest dinosaur.
The first dinosaur.
That's the first one. And it was also, for a while, known as the first lineage to the predatory dinosaurs, until more recent findings have pushed it actually more toward the herbivorous side of things.
Yeah, because early dinosaurs are super confusing.
Because they're super weird. One of the dinosaurs that did that was Eodromeus, which is another early... These are all dating back to right around 230 million years ago.
Yeah.
And, so, give or take a couple.
So that's still Pangaea time.
Yes.
Right? We're still not quite broken away yet.
Like, so this is... Things are starting to break here, but these two dinosaurs are both smaller, lightly built, two-legged. Eoraptor seemed to have more omnivorous teeth, while Eodromeus seems to be much more predatory. And that finding was actually what made them push Eoraptor more toward the herbivorous side of things, and it very likely could be a basal sauropodomorph. So we're still teasing all that stuff out, and now we have this giant Gnathovorax hanging out in the same area. Now, one difference between those that I want to mention here is that both Eoraptor and Eodromeus come from Argentina,
Yes.
which is a place you're going to hear a whole bunch about as we continue through our dinosaur list. Because Argentina has a lot of dinosaur fossils.
Big deal place for dinosaurs.
Oh my goodness. Many of the big notable ones are from the Cretaceous. We do have some Spinosaurs, which we've mentioned before
In episode 42.
Yeah. So Irritator is found here, and Oxalia, both from Brazil. We get things, Ceratosaurians, which are same group as Ceratosaurus, the famous three-horned predatory dinosaur. I pulled this one out mostly because of the name, because it's Velocisaurus.
Yep.
Which is fun. And this is a moderate size, so we're looking at probably around 5 feet long. Predator, Argentina, once again. The Ceratosaurians, there are a number of dinosaurs that seem to be related to that group here, which is a much wider group that includes other dinosaurs in it. But probably the most notable group of predatory dinosaurs are the Abelisaurs.
Yeah.
Which are very South American.
They're basically Gondwana's answer to the Tyrannosaurs.
Yeah.
That were taking over the northern continents.
And so, huge variety of them. Many of them just look like your big theropods, but not all of them. My favorite of the South American dinosaurs doesn't look anything like any of the others, which is Carnotaurus. Oh man, so Carnotaurus, made famous by the Disney movie Dinosaurs, which was my favorite part about that movie because the rest of it's weird, was found in Argentina. There's only one species known, Carnotaurus sastrii.
And only one individual.
And only one specimen.
Yeah.
A well-preserved specimen, but just one.
Yeah.
So as far as like specimen to fame ratio goes, Carnotaurus is doing pretty well.
Not too bad.
This is a lightly built predator, bipedal, somewhere in the vicinity of 25 to 30 feet long, and weighing a little more than a ton, maybe ton and a half. Notable for large, thick horns over the eyes, a more snub-nosed skull with a powerful neck, and itty-bitty vestigial arms that, like, proportionally are even more dinky than T-Rex's.
Oh, yeah.
So these itty-bitty arms, stubby face, powerful neck, and then long, slender legs.
Yeah.
So a very oddly proportioned predator.
And this is how the very characteristic of what makes Abelisaurs so weird and strange is the pug faces, really tiny arms like the Tyrannosaur, the famous Tyrannosaurs up north, and then those long runner's legs, like very much among the most diverse large predators in the south that didn't hit it big in the north.
Yeah. Now, speaking of big predators, we can't go through South America without mentioning Giganotosaurus.
Yeah, that's a pretty big one.
Whew, and big. For a long time, this was making all the headlines for being the new biggest predatory dinosaur of all time. One of the largest specimens gives us a size estimate range of between 39 and 43 feet long, a skull that's somewhere 5 to 6 feet long, and total weight of this one has a large discrepancy because weight's weird.
Yeah.
4.5 to 15 tons.
Yeah.
It's big predatory dinosaur.
So T-Rex sized, Carcharodontosaurus sized, Spinosaurus sized. It hits that little. It's in that exclusive little group of. This appears to be as big as theropods ever got.
Yeah. And that's one of the things one research noted that was looking at actually comparing known sized predatory dinosaurs and seeing how the skull compares, because skull size is a typical way to try to estimate what total body size and weight would be, and that it's not really reliable. So
no,
T-Rex size is the best way to say it. Though it is in the same group as Carcharodontosaurus. So
yes, it is.
Same group, which means it has a much more narrow head. Think more Allosaurus if you're needing popular dinosaurs to compare it to than T-Rex, with very serrated teeth though still.
Yeah, Tyrannosaurus had the big, robust, beefy head.
The Doberman Pinscher.
Yep. Whereas Carcharodontosaurs, like Giganotosaurus, had the sort of more axe-shaped.
Yeah.
It's narrower, it's a little bit longer, it's tall. And then your Spinosaurs, sort of the other group of stupid big ones, had croc faces.
Yes. Some people have suggested that the reason for the more narrow axe-shaped face is it's better for slicing in to big prey. And it's been suggested that potentially their big prey could have been the biggest of prey. The titanosaurs, which are not only known in South America, but boy, are there a bunch of them down there.
I want to say, and I don't know this off the top of my head, that they either start down there or are most diverse down there, or maybe it's just that they were first identified down there. But South America is famous for titanosaurian sauropods.
And so these are sauropods being the big long-necked dinosaurs, titanosaurs, as the name suggests, ridiculously big.
Yeah, even for sauropods.
These are... These also have the biggest of dinosaurs. Not just sauropods, but of dinosaurs.
Of land animals.
And of land life, yeah.
Ever.
So, two of the big names there is Argentinosaurus.
Naturally.
Which is found in Argentina. And the more recent Antarctosaurus. You've probably seen these names pop up in more of those articles of like, new biggest! Yeah. Once again, these are usually very partial specimens, though some have been in good condition. We're trying to estimate from not all of it, and we're estimating within very close margins. Yes. And just because one statistical analysis has a technically bigger upper limit does not mean it was the new biggest dinosaur. But both of these are ridiculously big, coming at, somewhere around 98 to 115 feet long and 88 to 100 tons.
Yeah.
So, massive animals. I did like that I was able to find some limb lengths. So, a fibula from Argentinosaurus, so this is lower back leg bones, was 1.5 meters long.
Jeez, that's a fibula.
And a femur on Antarctosaurus was 7.7 feet long, 2.3 meters.
So these are the famous dinosaurs that you get pictures of the paleontologists that find them laying down next to their femur.
Yep.
To show that thigh bone is longer than they are.
Yes.
One of these South American titanosaurs is also Patagotitan.
Yes.
Which is the one that is now at the museum in New York that fills an entire room.
Yep.
Argentinosaurus fills an entire room down at the Fern Bank in Atlanta.
Big dinosaurs.
They're so big.
But sauropods were not going to be left out of the weird dinosaur race. With Amargasaurus. This is a sauropod, much smaller, just a moderate, 30-ish feet long.
Yeah, that actually is a rather
small
sauropod.
It's a very moderate. But this, once again from Argentina, this sauropod had long spines, 2 rows of long spines going down the neck and back that just look like these big porcupine protrusions, and one of my favorite sauropods just because it's so ridiculously decorated. I've seen multiple things that suggest that they may have had keratin coverings or some sort of skin covering, but it has these large spines, more notable than any other sauropod, at least for that kind of display.
Most often I see them reconstructed as dual sails.
Yes, that's what I see often.
The back of the neck.
Yep. So yeah, weird times during the Mesozoic, weird creatures.
Yeah, it was. It was a weird time already.
Mm-hmm.
For interesting dinosaurs, it's a sort of place to look for Gondwanan forms, and important for paleontology.
Yes.
Because it has so much unique and intriguing Mesozoic life.
Well, and early stuff. Like, that's one of the most exciting things. Like, it has a lot of my favorite weird dinosaurs, because I like weird stuff.
Yeah.
But it also has that early stuff, which is critical. Like, that is such a gap in our knowledge of dinosaur evolution. Now, I know there's other stuff that was alive during the Mesozoic. I know I just focused on a bunch of dinosaurs.
Yes.
There are going to be some things I mentioned later on that were still alive during here, so don't worry, everybody. But once again, it's a lot of this continent.
We're real sorry.
So, at some point, just ask us to go over the Mesozoic of South America, and I promise we'll go over different stuff. But for now, let's take another step forward in time and look at what things are like after the Mesozoic, running toward today.
In the age of mammals.
In the age of mammals. after the demise of the dinosaurs and Mesozoic life,
Episode 5.
we enter the Cenozoic.
Age of Mammals.
And here's where we really start to see South America distinguish itself from the other continents in that it becomes isolated for a major chunk of this time.
Episode 4 and 50 and 40 we talked about what happens when a landmass becomes separated and your life is now cut off from exchanging evolutionary info with its neighbors.
So during the beginning of the Cenozoic, we see it start to, it solidifies its disconnect with North America. It is still connected to Antarctica, but Antarctica starts disconnecting with Australia.
Yeah, and also getting colder
Yes.
before too long.
And so we're seeing that start to break up. And by around 34-ish million years ago, South America comes away from Antarctica.
Yeah, the Drake Passage opens.
Yes, and becomes fully isolated from every other landmass, and stays that way for the majority of time leading up to today. About 10 million years ago is when we see it start reconnecting. So for the better part, over 20 million years, it's on its own.
Yeah.
And this is when a lot of weird stuff happens.
And it gets up to some crazy stuff.
Oh, man. So we see lots of cool stuff. We're going to jump right into the cool, weird animals. Some of these we've already mentioned, so they will get... you can go listen to those episodes. Terror birds being one of those weird...
Oh, yeah.
They just weird groups that reign supreme. The forest racids.
Yep, episode 37.5, we talked about the terror birds.
Yeah, one of our few 0.5s.
Mm-hmm.
These were those predatory, flightless, often very large
Yeah.
birds that became, for a time, the dominant predators in certain parts of South America, and lasted actually until very recently. This is one of the few groups we'll talk about that came way up until recent times.
Yeah, they were in South America for almost all of the Cenozoic.
Yes.
Because they show up right after the end of the Cretaceous.
It's dinosaurs reclaiming their throne.
Yeah, exactly what it is.
We also see some other old members of dominant lineages trying to hold that previous title, the Sebecosuchians.
Ooh.
This is a group of mesocrocodilian, so cousins of today's crocs, so we're fairly close actually, but almost fully, or as far as the specimens that have found so far, fully terrestrial and predatory.
So South America already
Mm-hmm.
kicking off the Cenozoic, terror birds and land crocs.
Yeah.
It's a
Now,
cool place.
This group actually predates where we're talking about right now. They showed up in the Jurassic and lasted till the Miocene.
Oh.
But certain groups were more prominent at different times. Two of those were the families Sebecidae and Braurosuchidae. Braurosuchus, being the famous member of the latter group, was noteworthy during the late Cretaceous in Brazil. So there you go, some other Mesozoic stuff.
Yeah.
This is a 10 to 13 foot long terrestrial mesocrocodilian with narrowed snout, flattened serrated teeth, and some of the other hints that give us that it's terrestrial that I liked and I had not actually heard specifically mentioned before about these kinds of groups is the nostrils are on the front of the snout like most mammals, not on the top.
Huh.
Yeah.
So it's just... It sounds like the Triassic, like Post-Osuchus
Yes, it does.
type animals.
The nickname I coined when I was teaching my coworkers about these types of croc relatives back at the aquarium was wolf crocs.
Ooh.
Which, yeah, I mean, it's a catchy phrase. These are all features that are shared by basically all of the Sebecosuchians, and seems to be a trend in this group. Sebecus, being the famous species that showed up during this time in the Eocene of Patagonia,
Ooh.
was more moderately sized. I think it was typically like 5 to 7 feet long.
Okay, no big deal.
No big deal. I mean, that one you can take. But fun note on that one, it is named after Sobek, or Sebek,
Oh.
the Egyptian crocodile-headed god.
So in the Eocene, now we're in the Cenozoic, which means that this creature, along with early terror birds, is hunting mammals.
Yes, like running around the forests of South America hunting.
Whew.
And previously they thought these croc relatives might have been semi-aquatic, but it seems like no, they are fully terrestrial. Their femurs have features that seem like their legs were under the body, made for moving.
So it's just the Triassic again.
Yeah.
We're back to the Triassic. Wow.
Now, not to be left out,
Nope.
the water also has its juggernauts. Two of the coolest big fossil animals ever show up after the Mesozoic. First comes in Titanoboa.
Titanoboa, episode 3, the largest snake in the fossil record, unlike the theropods, right? And the titanosaurs, where we were talking about how there's like a bunch of different ones that kind of fit that top category. Titanoboa is the largest known snake by a ridiculous margin.
It's silly how much you have to jump.
Anacondas today come in at over 20 feet long.
Mm-hmm.
Reticulated pythons up in the 25-foot range. Gigantophus, which was at one point considered the largest snake ever, was estimated at over 30 feet. The most recent length estimates for Titanoboa are around 45 feet long and built like an anaconda.
Yeah.
It's so big. It's stupid big. Probably eating fish.
Which, yeah, I mean, it's a readily available food source.
And there were big fish.
There were big
so
fish.
Titanoboa is from the Paleocene,
Mm-hmm.
so very earliest Cenozoic of Colombia.
Yes, it is. And so that's we're looking at the top of the continent there, while Argentina is down into the southern portion. I forgot to say where that was.
Yes.
In case you don't have a map in front of you.
Titanoboa also lived alongside bite-sized crocs.
It did.
Yum, 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 yum.
Yes. Now, speaking of non-bite-size crocs, Purosaurus
Yeah.
is my contender. This is the biggest caiman that has ever lived, and one of the biggest crocodilians that has ever lived.
The three big crocodilian, like you got for those who like these animals,
Yep.
Dinosuchus, which is a gator cousin, Sarcosuchus, who is a croc cousin, and the caiman, Purosaurus.
And the caimans were not going to be left out. This is in the Miocene, so more recent. This is caiman that comes in at estimated lengths of somewhere in 30 to 40 feet long, with a skull that's up to about 5 feet long, but also just beefy, like more like a T-Rex skull than a slender croc skull. And I've seen estimates for its bite up in like the 7 tons bite force range.
Wow.
Found throughout South America as well. Brazil, Colombia, Venezuela, and in the Amazonian region. So this was a prominent species during this time. This would have been one of the biggest predators in the continent.
Cool.
During that time. So yeah, South America was awesome.
Also, we should point out, in the same general area, if I recall correctly, as Titanoboa, Stupendimes.
Oh yeah.
The largest freshwater turtle.
Yes, absolutely.
Which was, now, and I don't have it in front of me, so I'm going off the top of my head, like 7 or 8 feet long or something
I always
ridiculous.
see it compared to like a dinner table.
Yeah.
Like.
Just huge.
Big, cool reptiles.
Yeah, double check me, listeners, on
Yes.
that. Look up the numbers. Don't quote me that. I don't have it in front of me, but it's big.
We could go over all sorts of cool animals in this group, but Shaley specifically asked for cool, weird South American mammals.
So let's talk about mammals.
So let's focus on those, because South America has really neat mammals. Part of this is because of what it was connected to and what it was isolated from even before this time of isolation. And it is one of the only other continents well known for marsupials.
So a bit of background on marsupials, dear listeners. So your mammal family tree today is mostly one major group called placentals.
Yep.
And then a whole different group called marsupials, which are your kangaroos, koalas, mammals with pouches.
Yes.
Mammals that have too many teeth and too many vaginas, and there's all sorts of weird things with their reproduction. And then there's monotremes, but they're a whole other thing. Today, marsupials are almost entirely restricted to Australia, but last I heard, it is thought that they originated in North America.
Yes, and that they actually moved through South America, through Antarctica, into Australia.
And today, most of them are limited to Australia. They are gone from Antarctica, surprisingly enough.
As most things are.
A bunch are still in South America, and we have one marsupial species still native to North America, and it's our friendly little trash divers.
Yep.
The Virginia opossum.
The Virginia opossum. And even though Australia's the one known for it, South America still has a bunch.
Yeah.
Somewhere around 90 species.
Lots
still.
of possums.
Lots of opossums. And I found out difference between opossum and possum. Possums are Australian and a different group than the opossums.
Oh.
Yeah, the O's important.
Huh.
I always just thought it was people being pretentious.
Well,
Yeah.
there you go.
The opossums, the Didelphimorphia, are the New World opossums. These make up more than 90% of South American marsupials. So
Right.
you're basically talking about opossums if you're talking about South American marsupials.
Today.
Yes. And so these are ranged wide. They have they've been in South America for quite some time. They have a good fossil record there. We have the Virginia opossum that makes its way up to southern Canada.
Yeah, it's just like
Wow. And then the Patagonian.
Soon.
Yes.
I'm holding the fort, sisters.
The Patagonian opossum goes all the way down to southern Argentina, but most are in the central areas of South America in the subtropics. Those are your most common today, but if you get into extinct stuff, you get really cool things. The Sparasadonta marsupials, which may not be definitely marsupials, but may be proto-marsupials. But
Okay. Marsupial cousins.
close cousins of marsupials at minimum, were a group extinct now that were the main mammalian predators in South America.
Marsupial predators.
Which we do not have much of nowadays.
I think the largest definitely living, sorry,
Yeah.
thylacine enthusiasts.
Yep.
Marsupial carnivores today are the Tasmanian devils.
Yep.
Which are not big.
No.
And even the thylacine was, coyote wolf size.
Yeah, I mean, so it's, big enough to be a threat, but not, something to put in the record books. Some of these got up to bear-sized.
Yeah.
So some of these were big. These dominated the predatory category down in South America, especially because there were no placental predators to compete with. Once they did have to compete with those, the competition did not go in their favor.
Sorry, marsupials.
Yeah. But they do have one of my favorite fossil mammal predators on the list, which is Thylacosmilus.
Thylacosmilus.
Oh, it's so cool. Thylacosmilus is a convergently evolved marsupial to the saber-toothed cats.
Yep.
It is very cat-like in shape. It has two prominent saber cananiform teeth and was about the same size. It was a little bit smaller than Smilodon, but it was about jaguar-sized. So it was not small. And even had some of the similar characteristics. It had beefy neck and shoulders and forelimbs. So it seemed like it was able to wrestle with its prey. But my favorite thing about it is its saber teeth were notably different in that they were open-rooted.
Yep.
And those roots arced above the orbits, the eye sockets. And so these were saber teeth that could perpetually grow.
They were like rodent incisors.
Yes!
They grew forever.
Which is so awesome!
Because when marsupials are like, hey, placentals are doing this thing, what if we did it, but weird?
Yeah. And so this was a major predator during this time. As far as I know, we have as little understanding of what it was doing with those sabers as we do with saber-toothed cats.
Yep.
When I was looking this up, I found videos that were, very much emphasizing these were convergently evolved tools for taking down prey bigger than themselves. But as we talked about a few newses back, that's not what it seems like they were used for. So cool marsupial predators, as well as bukus of opossums.
Yeah.
Just all the opossums you could ever want. There are other marsupial groups there today that are range in sizes, but most don't get very big nowadays. They're opossum-sized and down. The other uniquely South American mammal group, and famous one still today, are the xenarthrans.
Yeah.
Oh, once again.
Now, we were just talking about how marsupials are weird.
Yes.
But if you leave out the marsupials and you look just at the placental mammal family tree,
yeah,
then that crown goes to Xenarthrans.
Xenarthrans to the marsupial. We learned it from you.
So this is your armadillos.
Yep.
And their cousins.
Yes. Sloths.
Sloths.
And the anteaters.
And anteaters.
So all very unique, weird groups of mammals, connected by the source of their name, which are the extra weird connections on their vertebra, and also all have weird big claws. That's something I've always noticed, and it's always stood out to me, especially since they're using them in different ways nowadays.
Yeah.
So
They also have very odd teeth.
yes, they do. Their dentition is weird.
Very strange, because I think they all, again, I don't have my notes, but ever-growing,
Yep.
and they don't have enamel?
Yeah. At least I
think
know
it's- I think
sloths
it's the-
don't,
yeah,
and
yeah,
I'm 90% sure armadillos don't, and most anteaters don't have teeth.
Right. So they're just really weird. Once again, I don't have notes in front of me, so
Yeah.
don't quote me on all the... But they're so weird.
They're just
weird mammals.
Bizarre. So Pilosa, which includes sloths and anteaters, is the smaller of the Xenarthran groups, only being 2 sloths nowadays. But the fossil record of sloths in South America is huge and intense, which is why we did a whole episode and talk with sloth experts on it. So
Episode 24 and the sloth Q&A.
so go listen to that, because there's tons of cool information there.
Most sloths were ground sloths.
Yes.
From little, something like black bear sized or such, to just monstrous
Yeah,
sloths.
some of the biggest land mammals.
all over South America.
So sloths were doing great up until they weren't. Anteaters, it seems, have never been a super numerous group. Their fossil record's very sparse, and today there are only 4 modern species. Now they're very diverse. You have arboreal, you have land based anteaters. The giant anteater is actually like large dog sized.
Yeah.
So I mean, it's not small, but not a lot of anteaters. Not a lot of information on what they used to. They seem like they've always been kind of, moderate in their diversity.
Just doing their own thing.
Yeah, just chill anteaters. The cingulata, the armadillo side of things, that's where the Xenarthrans focused all of their efforts.
Oh yeah, that's another thing Xenarthrans tend to have. Osteoderm.
Yeah,
Bones in their skin.
that's a feature of this group.
Like some kind of reptile. Not that I'm complaining about reptile features.
You're emoting a good reptile there, but armadillos are about 2/3 of living Xenarthrans, and hugely successful. They show up here in North America, all the way down to South America.
Today.
Yep. So all over today, and were also successful in the past. Notable extinct groups, ones that don't look like what they look like today, are also big members of this group. You have the famous one, the Glyptodonts.
The Volkswagen beetle.
Volkswagen beetle. Big igloo-shaped armored shell of osteoderms. Glyptodon measured 10 feet long, including the tail, and 5 feet tall.
So an igloo.
An igloo.
Made out of flesh and bone.
Yes.
With a tail that had spikes on it.
Oh, and like 2 tons.
And just enormous.
Just massive.
Famously discussed in episode 70, convergent with
Yes.
the armored dinosaurs, the ankylosaurs. Famously discussed in episode 69 of the Common Descent podcast.
Which, also a notable thing for them, one of the only other animals to truly converge with ankylosaurs. Like, no one else had the cojones to do it. The Glyptodons.
Tail clubs. They were like, those guys had the right idea.
But there were other big members. The Pampathirs weren't as big, but they were basically just giant armadillos.
Yeah.
These got to be like 400 pounds.
That's a black bear.
That's a black bear. And like 3-banded armadillos had armored shells with flexible bands, movable scoots. So it could have actually, maybe not rolled up all the way, but it could actually have moved and been more mobile. So picture something the size of a black bear, but running all weird like armadillos run. So like big armored mammals running around South America, doing whatever they want, I guess. And then you get into the really weird stuff, just because it's like even the name of this group, which is often called the native ungulates.
Mm-hmm.
But they're not actually ungulates.
So your ungulates are your hoofed mammals.
Yes.
around the world, right?
Mm-hmm.
Your horses, your deer, your antelope, your giraffes, like hippos and rhinos, like I walk out on the plains, I walk through the forest, I eat the plants, this is what I do. Classic herbivorous mammal form today.
These are often called native South American ungulates, or some version of that. Not because they're true ungulates, but because they are super similar.
Yeah, they have convergently evolved.
Yes.
This is South America's answer to ungulates around the world.
And for many of these groups, it is still unsure of exactly how close or far they are from true ungulates. Some of them actually seem to be fairly close in relation. Members of the initial split between ungulates and this group. Many of these did actually have hooves, but not all of them did. There were some that had nails and claws or something in between. So weird stuff. But all were herbivorous, which is another very ungulate trait. The Noto ungulata, which there in the name is not quite.
Not an ungulata.
Included things that were similar to everything from rhinos to hippos to rabbits to rodents. So very diverse, lots of different shapes.
Herbivore.
Unarmored
herbivores.
Yes. These, many of these actually evolved ever-growing hypsilonodont teeth like rodents. So premolars and molars that would just keep growing as they grinded them down. So open-rooted once again. Several of these survived until recently into the Pleistocene. Some as recent as just 2 million years ago or so. Toxodon is one of the famous members of this group because it was discovered by Charles Darwin.
Yeah, I was waiting for the moment to bring this up.
Mm-hmm.
South America's mammal fossil record is also historically super important.
Yes, it is.
Because finding fossils in South America was one of the big things that Darwin did on his big journeys, episode 28.
He collected tons of fossils. It was a huge inspiration for his hypothesis of natural selection.
Yeah, one of Darwin's toxodons we actually printed at the fossil site not too long ago off of a scan taken at, I think it's the London Museum that has one of his toxodons.
Oh, yeah. I was reading one of the articles talking about them scanning that. That's super cool.
Yeah, it's in my office.
Yeah, I'm going to go look at that later on. Toxodon, late Miocene to Holocene, has the species Darwin discovered had a skull about the size of an elephant's. Which he bought for, as the article I read said, $1 shilling and 6 pence. So about $7.50 in pounds today.
Yeah.
So, nothing. This resembled a very heavy rhinoceros.
Mm-hmm.
So, big-bodied, 8 to 10 feet long, and probably not quite 5 feet at the shoulder. Tall. So, big rhino type animal, 3,000 pounds. So, heavy set herbivore, which is notable since there's not a thing we find a lot of in South America today.
Nope.
Much like North America, where we lost a bunch of our big herbivores, but we used to have bukus of them. South America, as you'll see as we go through this list, was very similar. This one also had giant rodent-like teeth, which it said Darwin was thrilled at the idea of a rhino-sized rodent. But now we know it's part of the Noto ungulata. Another member of these South America kind of ungulates are the light-top terna, which are kind of antelope camel-esque mammals. I know we're doing the thing we always accuse things of doing with marsupials, of just comparing them to the more notable version. Right. That's kind of what these animals are.
We talked about one of these way early on, Macrocania, which was in the news a bunch, because there was a whole big new study about what exactly it is.
Mm-hmm. And the DNA analysis that was done there showed that it actually seems like these are a sister group to perissodactyls.
Horses, tapirs, rhinos.
Yes, so the ones that stand on their middle toe. These two lineages seem to have split about 66 million years ago, and this is one of the sister lineages that was prominent in South America. They were very camel-esque in shape. Not today's camels with humps, but like the llama, very slender, long-necked, long-legged, but the skulls seem to suggest that they may have had a tapir-like trunk.
Yeah.
Which also seems to be a theme.
But why?
With a lot of these weird mammal groups in South America.
Now, that being said, perissodactyls, noses, lips, mobile,
Yeah.
upper lip, that's, not too unimaginable.
Yeah. That was my favorite part about going to petting zoos as a kid, was watching their lips go and just pull the food in. So you have these weird camel-like things. The Astrapotheres are another, it seems, somewhat trunked group of mammals. Less diverse than the previous two, and tusked. These were medium to large sized. Seems like they might have had that proboscis. Also potentially kind of semi-aquatic, so they kind of sound like big tapirs.
Like warthog tapirs.
Like warthog tapirs.
Huh.
These Astrapotherium, for one example, got up to sizes of about 8 feet long and 2,000 pounds. So like
A rhino again.
Yeah.
Or a hippo.
Yes.
It's got those tusks.
Yep. So it's like a little potentially trunked. It's hard to confirm that.
Yeah.
But little, hippo-esque thing. I say little.
So South America's got its own version of hippos,
Mhm.
its own version of rhinos,
Mhm.
its own version of weird antelope type things.
Yep.
It's doing its own whole thing.
So the only thing it's missing is something elephant-sized.
Well, yeah, which obviously it just never got.
Yeah. Pyrrhotheria,
Oh.
large elephant-like mammals as they were described. They were large, very tapir-like again, 5-toed feet, digitigrade, slender limbs, and only found in fossil sites older than 25 million years old, and only close up to that. So they
Early Cenozoic.
early Cenozoic and medium range, so they're not as well known, or a smaller range of time. Not as well known as the others, but Pyrrhotherium got up to be 10 feet long, 5 feet tall at the shoulder, and 7,000 pounds for the estimate. So they even had things that were, it's not quite as tall as our
Right.
elephant.
It's approaching elephant size.
But it's weight-wise, it is a
It's getting
big herbivore. And once again, South America just seems to be made for things shaped like tapirs.
Yeah, apparently it's just where you do a taper thing.
Yeah. So bunch of these kind of ungulate, kind of hoofed mammals. And then you even have non-therian mammals down there. So non-therians are those groups that include the monotremes.
Mm-hmm.
Therians being marsupials and placentals.
So monotremes today are that third, like all of the mammals' weird cousins.
Yep.
Your platypus and echidna,
Mm-hmm.
which are egg-laying mammals that don't have proper lactation
Yep.
the way that standard mammals do. They're barely not reptiles.
Yes. And nowadays only found in the Australia region of the world. So Australia, Tasmania, Kangaroo Island, and New Guinea.
Mm-hmm.
But at least one species made it to South America. Monotrematum subamericanum. So they even had one of the egg-laying weirdos
Weird.
for a time. Another non-therian they had that's unique to the southern continents was Gondwanatheres, which I just love that name.
Yep.
These were kind of gopher-esque, it seems. Very small, somewhat rodent-like, with very tall teeth, grinding teeth. But they're known from only the continents that were part of Gondwana and have been found in South America as well.
Neat.
Yeah. Lots of weird mammals. Lots of unique things. Once again, we could dive into these, each group really could get its own attention.
A couple groups that we should point out is that somewhere in the middle of the Cenozoic to the late of the Cenozoic or somewhat, South America receives
Absolutely.
primates and rodents.
Yes, one article I was reading called Lucky Arrivals.
Yep. We talked about this. Episode 7, we talked about this. With Ethan. New World monkeys
Yep.
hop over to the Americas, and caviamorph rodents.
Yes.
Which become your guinea pigs, New World porcupines, capybaras.
Capybara, biggest rodents nowadays.
Biggest rodents in the world. Those are branches of these groups that landed in South, and largely are South American groups today.
And surprisingly enough, do not seem like they came from North America, but Africa.
Yep. Rafted across the oceans.
Yeah. So even though it'll eventually connect with North America, its first foreign invaders were from Africa who it used to be connected to.
Across the sea.
Which I think is very interesting.
Yeah.
It does also have notable primates, things like the tamarins and marmosets, the spider monkeys and capuchins, both of which have those prehensile fifth limb tails.
Yup.
And then the flat-nosed monkeys, which I just love those. They're so weird. You get howler monkeys and a bunch of, like, tons of primates that are notably different still from primates in Asia and Africa, because even though they came from Africa, they were isolated long enough to get weird and unique.
Yep, whole new branch of
Like,
the primate tree.
Some of them getting rid of their thumbs and stuff, that's the first time I learned about that. Some spider monkeys got rid of their thumbs because it was easier to hook onto branches. It's like, but that's
your thing.
We gave you the primate member card because of that.
It's like all the tetrapods that lost their limbs.
Yeah.
What are you doing?
I remember the first time I explained that term of tetrapod to someone, they're like, but it means 4 limbs. Yes.
Sure does.
But they don't have those. Nope. You're right on track so far.
Moving on.
We also had bats show up in South America.
Naturally.
Very early on in their evolution. They still seem like they probably evolved originally in North America from the very sparse fossil record they have.
Mm-hmm.
But they've been in South America about as long. So South America is also riddled with bats.
And some unique bats.
Yes. They are very well known for certain members, like vampire bats, which are almost exclusively South American.
Mm-hmm.
Which are one of my favorite. South America's got a lot of... I'm always accused of overusing my favorites, but man, South America hits.
It's got a lot of cool stuff.
Hits my check boxes. And so this is bringing us, though, very rapidly toward more recent events. Because, as I mentioned, South America was isolated, but as we know now, it did not stay that way.
No, it didn't.
And so, as we get toward the end of the Cenozoic, the connection, the land between North and South America begins to close as islands rise and sea levels fall, until eventually there is a bridge.
Which leads us to episode 43.
Yes, it does.
The Great American Biotic Interchange. So, South America has been isolated, doing its own thing, all these cool animals, and one might wonder, well, but what about all of the cats and bears and elephants and tapirs? Tapirs are super famously South American now. Those are all North American things.
Yes.
And when the American Biotic Interchange happens, all those cool North American animals go south. A bunch of the South American stuff starts showing up in North America. Your sloths, your armadillos, your porcupines, your possums, things like that. And this exchange also spells the end for a lot of those cool South American forms.
Yeah, unfortunately, placentals seem to, at that time especially, seem to be the new hot thing and the way of the future, and just outcompete consistently whenever they encounter the marsupial or other mammalian competitors.
Yeah. And indeed, even placentals like the notoungulates and the cool South American placentals, North America has been connected to Asia for most of the Cenozoic, which means there is an enormous diversity of ecosystems and environments. And basically, one of the things that happens when you're isolated is you are exposed to relatively few environmental pressures. So all these animals up in North America that had been exposed to all of this, millions and millions of years of all sorts of migrations coming in and out, things from Eurasia. South America didn't have any of that. So the North American stuff was probably better suited to change and putting up with new things.
And competition.
So a lot of the cool South American stuff fades out when the Gabby happens. But we did a whole episode on the Gabby. Go check out episode 43.
I just thought of what might be one of my favorite metaphors I've come up with to explain connected landmasses versus isolated when it comes to this stuff, and it's online gaming. In that North America was playing online with competitive ranked servers. South America was a private server.
Yep.
And anyone who's ever switched from private to public knows that you immediately just get destroyed.
Oh, yeah. Well, the North American players have been playing the Korean players for like years and years, and now,
Yeah, it's you've gone from playing the story mode to online, and it's not the same. It's not the same.
But still today, South America holds on to a lot of its really unique, cool stuff.
And a big part of that, a big part of what makes South America still unique today is its ridiculous amount of, or chances for biodiversity. It has ecosystems that hit just about every mark that any random animal could ask for. So there's a dry area, there's hot areas, there's cold areas. But then you also have these dense biodomes of the rainforest that just, there's enough room for every weirdo to find a niche somewhere.
Yeah.
So it's still being weird today and awesome. And we're still finding new stuff in it all the time.
Yeah, it's a cool place.
It's so cool. Once again, if there's some part of South America that we just didn't get to that you really wanted us to get to, please make a request because we would love to come back
Oh, yeah.
to the America down south.
As always.
But before we wrap up the episode, a little tidbit of extra. So at the beginning, we shout out some patron names because they were at a certain level. If you're also at a certain level on Patreon, you can ask us questions that we answer here on the podcast.
Sure do.
So I have a question from one of our patrons.
Oh, let's hear it. Is it in a pirate voice?
No.
Oh, okay.
Could
you? But you could read it in a pirate voice.
Is that going to become the new thing?
No.
Because I'm game for that.
If you want your patron question read in a pirate voice, you have to write it in pirate speak.
No, you have to do some work.
We're not taking this away from our dread pirate friends.
Because I was about to say, if you better be careful what you suggest, because I was ready.
We've opened the doors. It's gonna get weird.
Tom asks, why do ichthyosaurs not have a horizontal caudal fin a la dolphins, but rather a vertical one a la shark/fish, etc.? I assume it's to do with locomotion and thinking of lizards with the side-to-side action that would have been transferred, but happy to be corrected/educated.
An excellent question. Yes, dear listeners, Bask and Coil, you may have noticed that aquatic mammals, dolphins, whales, and indeed pinnipeds like walruses and seals and such, have horizontally flattened tails that they move up and down while they swim, whereas almost all other aquatic animals, fish, amphibians, reptiles, have vertically flattened tails that they move side to side while they swim, including ichthyosaurs, episode 97. And the reason for that discrepancy is mostly because mammals are weird.
Yeah.
So fish are the ancestral vertebrates.
Yes.
And fish swim side to side. Their bodies are built to swim side to side.
Yeah, that's how fish started swimming back when they started swimming.
And so every vertebrate inherited that.
Mm-hmm.
Right? The slithering of a snake, the side to side of lizards and crocs. And so when those animals go back into the water or become aquatic, they still bend that way.
Yeah,
the body still moves
already
that way.
moving in that way most of the time, and it just transitions into paddling.
So if you're an ichthyosaur or a mosasaur or a sea snake or a crocodilian, your tail flattens vertically, so it is tall and low, and you swish it side to side like a shark's tail. Mammals changed up the spinal arrangement.
Yes, we did.
In part, probably for running and such.
Yeah.
Moving on land. Mammals do a lot of crawling and a lot of burrowing and a lot of running and a lot of climbing.
Well, and if you're moving fully within the limits of gravity, up and down make more sense than side to side for moving quickly and efficiently.
So if you picture, if you've ever seen a documentary that shows you when cheetahs run.
Yeah, and they fold up.
And their body, their back is like a spring
Mm-hmm.
that's bouncing not side to side, but up and down.
I mean, a great example for anyone to try at home is not that everyone can just touch their toes, but it would be easier for me to ask you to stand up and reach forward to touch your toes than to reach over to one side, and because our spine doesn't bend that way, the ribs get in the way.
And so when mammals move back to the water, they tend to keep that up and down motion that you might use for running in their tails. So dolphins have horizontally flattened tails, outside to side, as do pinnipeds and such.
Yeah, you get some weirdos. Like I know there are seals that kind of flap their feet back and forth.
Yes.
Versus flapping their tail, and there's the nutria, if I'm right, that has the laterally flattened tail,
okay.
and it waves it like a ribbon, and then you get weird things like the plesiosaurs and pliosaurs that
sea turtles.
Yeah, that don't use their tails at all. But yeah, for the most part, if you're a reptile, you keep the fish mode, and if you're a mammal, you have to be weird.
Yeah, it's one of my favorite. It's one of my favorite examples to use for how ancestry
Yes.
is as important as function.
Yes.
That why do dolphins swim up and down? They don't have to. That's not better or worse functionally than going side to side. They're mammals.
Yeah.
Same reason ostriches have hollow bones.
Yes, exactly.
It's like, they're not flying with those hollow bones or with their feathers. They're birds.
It's what they started the game with.
There you go.
Yeah.
Ancestry.
Yeah,
Important.
I
so,
remember...
Tom, you are absolutely correct.
Yes.
Yeah,
On the
that's
mark.
exactly what it is.
On the mark. I remember the first time I was making that distinction, and I was trying to figure out if it was an efficiency thing, and I was looking stuff up, and it was like, because dolphins typically are much faster than most other fishy type things. They're very agile and maneuverable, but there's lots of things with like efficiency that are better on the other side of things. Yeah. So it's just what the tools you were given.
Great question, Tom.
Very good question. Very observant question. And with that, we can wrap up this episode.
South America.
Cool continent.
Done. 3 continents done.
Boom. I mean, we're like almost halfway through or something.
And I think they are the 3, well, keeping Europe as its own, I guess, weird thing.
Yeah.
Because Europe is considered connected to Asia most of the time when you talk about biogeography.
Yes.
We've done the 3 smaller continents.
Yeah.
Someone's going to say Eurasia.
Yeah.
And I'm
going to go, no, I'm sorry. I only deal in Gondwana.
Can't.
And
Eurasia. How could we even do... by all means, request Eurasia.
Yep.
Whatever you guys want to hear.
Yep. It'll be our first 0.5 and 0.8. And...
Yeah, right.
Well, listeners, thanks for joining us on this trip through South America and its weirdness. If you have questions, let us know. Once again, share your favorite weird South American thing.
Please do.
If there's something you want to hear more of, as always, let us know.
Find us on the social media. Send us an email.
There will be a blog post going with this episode with lots of pictures and links. Check that out. Go check our social media for the questionnaire so that you can add your voice to the eventual Q&A we will be doing for the end of the year.
Please do. Thanks to our requesters and all of our patrons. How often do we release episodes?
Fortnightly.
Every fortnight.
Yeah.
We release new episodes. 75's coming up. You know what that means, Bask and Coil. We're talking Extinction next episode.
Yeah, it's Extinction, and we're 3/4 of the way to 100.
Yeah, how about that?
We've hit another chunk of percentage, which I love.
Oh boy, oh boy.
That's cool. Well, see you then, everyone. I got nothing more to say.
That's it. Have a happy day.
I got nothing more to say.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.